All right, so section 11.1, we are starting a probability unit, and the first section just simply talks about different possible choices or possibilities for certain situations. So like the first thing that I would like you guys to think of is, think about how many different pairs of jeans do you own? On average, how many pairs of jeans do you have? How many different t-shirts do you have? Like think about it. Some people have 2, 3, some people have 10 or 50. How many different outfits can you make out of your clothes? Someone in period 1 said exactly 13. It was kind of funny. I'm like, ooh, you own very little clothes. Usually it's more. But this is what the first problem is about. Suppose you have 2 pairs of jeans, blue and black. That's very little, don't you think? And 3 t-shirts, 1 white, yellow, and red. How many choices of outfits do you have? Well, the one way to do this is to draw something that's called a tree diagram. So let's say we start with having the blue and the black jeans. And with each of the jeans, how many different t-shirts could we wear? Well, it could be white, it could be yellow, and it could be red. So how many outfits is that with wearing your blue jeans? 3. How many different outfits can we have with the black jeans? Same thing, white, yellow, and red. So we really have 3 choices for outfits here, 3 choices for outfits here. What is that all together? 6 choices. This would be the long way to do this problem with the tree diagram, but it kind of demonstrates the different possibilities, and you could see it very clearly. Let's try this next one. In your pantry, there are 3 kinds of cereal: Cheerios, Fruit Loops, and Cocoa Puffs. 4 different fruits: banana, strawberry, blueberries, and peaches. How many different 1 fruit, because that's important, we're only choosing 1, and 1 cereal combination are possible? So to do a tree diagram, let's do a Cheerios, and then Fruit Loops, and then Cocoa Puffs. So that's 3 choices for cereal, but with each of these, how many choices do you have with 1 fruit that's going to be added? You could have bananas, strawberries, blueberries, and peaches. How many different breakfasts are those for just Cheerios? 1, 2, 3, 4, because you could have 4 different types where you have Cheerios and 1 type of fruit on your cereal. How many different choices or different ways are we going to have for Fruit Loops? 4 again. And what about for Cocoa Puffs? 4 again. So 4 plus 4 plus 4 is 12 choices. Now, as the problems get more and more complicated, that would be a lot of tree diagrams that you have to draw and count. I want you guys to take a look at this. For the first example, we had 2 pairs of jeans, 3 t-shirts. What's 2 times 3? 6. And over here we have 3 cereals and 4 different fruit. What's 3 times 4? 12. So an easier way to do these problems is something that's called the fundamental counting principle, and this is for 2 items. You can choose 1 item from a group of M, so like number of jeans or number of cereal, and a second item from a group of N items, the fruit or the t-shirt. And then find the total of 2 choices by multiplying. So you multiply M times N. So in example 2, a restaurant offers 10 appetizers and 15 main courses. In how many different ways can you order a 2-course meal? Well, 10 times 15, because we have your appetizers and your main course. 10 times 15 will be, there are 150 ways to order your dinner. Why don't you guys read the next one to yourself and see if you can figure out what to multiply. Thanks. So in how many different ways can you create a 2-course schedule that will satisfy this requirement? Well, we have 15 psychology, 9 social sciences, and what is that going to be? 135 ways. All right, let's do a tree diagram for something that has more choices. So now this next person has more clothes to pick from. In your wardrobe, you have 2 pairs of pants, blue and black, 2 belts, black and brown, and 3 t-shirts, red, green, and yellow. Illustrate the number of different outfits that can be made. So before we actually start multiplying, because you probably know what the answer is going to be, let's start with picking blue or black pants. What kind of belts could we use for each of those outfits? Well, it could be black or brown, and that would count as a separate outfit. But with each of the jeans and the belts, how many choices do we have for a t-shirt? We could have a red t-shirt, a green t-shirt, or a yellow t-shirt. Same thing for this. Red, yellow, and green. Red, green, and yellow. Red, green, and yellow. So that would mean we have blue pants, black belt, red t-shirt. That would count as one outfit. Blue jeans, black belt, green t-shirt. That's another one. And then the yellow one. So how many do we have all together? If we add them up, you count how many you have at the end right here. 3 plus 3 plus 3 plus 3 is, what is it? 12. Yeah. So there's 12 ways that a different kind of outfit can be made up. So this is the fundamental counting principle, and it kind of shows you how you would do this for any number of combinations, because it doesn't have to be just 2, 2, and 3. You could have many, many, many more items. And basically the idea is this, that you multiply. The number of ways in which a series of successful things can occur is found by multiplying the number of ways in which each thing can occur. Okay? So you're basically multiplying your possibilities. Example 3. Next semester you're planning to take 3 courses: Math, English, and Humanities. Based on the time blocks and recommended professors, there are 8 sections of Math, 5 of English, and 4 of Humanities. Assuming no schedule conflict, how many different 3-course schedules are possible? So we would multiply 8 times 5 times 4 to get, what is this? 160 possible schedules. Next one, example 3. A pizza can be ordered with 2 choices of size, medium or large. Okay, so there's 2. 3 choices of crust, thin, thick, and regular, and 5 choices of toppings, ground beef, sausage, pepperoni, bacon, or mushroom. How many different 1-topping pizza can be ordered? So for size, we have 2 choices. For crust, we have 3 choices. And there's 5 different toppings to pick from. Notice we're not making a different kind of like 2 toppings or 3 toppings. It's only 1 topping, so we're just choosing 5. 2 times 3 times 5 is 30. Now this next one, we're actually, well, let's do it. A multiple choice has 10 questions. Each question has 4 possible answers. So there's 10 questions and 4 possible answers. What's the first thing that comes to mind? What's going to be the answer? Based on what I've been saying, people think 4 times 10, which is 40. But here's what I want. This is kind of a different type of question. If you select one answer for each question, In how many ways can you answer the questions? This is not necessarily asking in how many ways can you have a correct answer selected, because that's what people think of at first. Here's what we have. For question 1, how many choices do we have? 4. For question 2, how many choices do we have? Another 4. And so this is going to happen 10 times. 4 times 4, 3, 4, 5, 6, 7, 8, 9, 10. I got 10. And what that means is, one way of choosing a random answer could be choosing A for all of them, choosing B for all of them, choosing C, and then D. So that's one way. That's the 40 that we're thinking about, right? However, what if I chose A for the first one, but B's for the rest of them? What if I chose C for this and A's for the rest of them? That's many, 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 many more options. What if I chose A for this, but B for this, and C for this, and A for this? There's many, many more options. So this is kind of a special type of problem where we have 4 to the 10th power. Why don't you guys do that on your calculator to see what you get? How many different ways can answers be selected? What is that? 1,048,576 ways. That's a lot. All right, last example. Telephone numbers in the United States begin with a 3-digit area code, followed by a 7-digit local telephone number. So you guys have seen this, like for an phone number, we're just going to fill in, and then we have 1, 2, 3, dash, 1, 2, 1, 2. Okay? So that's basically what a typical phone number in the United States will look like. There's one restriction though. Have you ever heard anybody tell you a phone number that starts with 1 or 0? Oh, what's your phone number? 078, blah, blah, blah. No. Have you ever heard someone, like without the area code, have you ever had someone tell you, what's your phone number? 156. No, right? That doesn't happen. Area codes and local telephone numbers cannot begin with 0 or 1. That's the rule. How many different telephone numbers are possible? First of all, what are we choosing from? How many digits do we have available to pick from? 10, 9 or 10? No, well, is 0 a digit? 0 is a digit, yeah. Do you have phone numbers that have zeros in it? Yeah, right? So 0, and then 1, and then 2, 3, 4, 5, 6, up to 9. So how many digits is that? 10. There's 10 digits, single digits, to pick from. However, for an area code, how many do I really have to pick from for the first spot? 8, right? Why is it 8? Because which ones are we not including? 0 or 1. So the ones that you can pick for the first spot right here are 2, 3, 4, 5, 6, blah, 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 all the way up to 9. We are familiar with like 708, 847, 312, 224, right? But there's 8 different digits for this spot. How many digits for this spot though? It could be any number. So it could be 10. And then for this, 10. The local telephone number cannot begin with 0 and 1. So back to this, how many different digits do we have to pick for the first spot? Only 8, again, because we're not including 0 and 1. However, how many digits do we have for this spot? Well, there's 10 different numbers to pick from. There's 10 different numbers here, 10 here, here, and here. This is not a minus sign. This just mimics a phone number. Why don't you guys multiply 8 times 10 times 10 times 8 times 10, so on and so on and so on. See how big that is. How many different phone numbers are you able to get? What is this? So we have 3 and 3, so it's 400 million. Is it 6 billion, 400 million? Okay. That's why you're not going to find the same phone number, because there's so many different ways to create a phone number out of the digits from 0 to 9.